Now turn it on. It's a laminar flow. And then this one is a little bit more turbulent. Oh, there she goes. A little bit more turbulent. That one's super laminar. Oh, and then there it goes turbulent. That's cool. Put your finger in it, and then boom.
It's like the water fountain, right?
Yeah.
Ah, I got
So, one way of conceptualizing electricity is that it's like the surface of a phenomenon called the ether. And so what we think of as electricity is just the surface. So if it's moving in a laminar flow, like a Birkeland current, you don't really see very much of it, but this same very minimal surface can be broken up into a ton of surface perturbations like that. You can make the same amount of water have a lot more surface by spreading it out into little droplets. Come on, no, come on. Come on. Come on, come on, come on. Okay, go pee. So that's what's happening when, frankly, with like power lines, there's laminar flow current, like very minimal that you can barely see in the movement of the electrons is like the surface of that laminar flow current, and then when it hits the light bulb, the light bulb takes that current and breaks it up so that it becomes electromagnetic versus etheric. And so it's turned into electromagnetic radiation.
here. I can watch that movie with you.
This one over here,
Uh-huh.
oh, it's a Christmas movie. So the electromagnetic field that people talk about, like the thing that makes magnets move. Yeah, the thing that you feel with refrigerator magnets, right? But it's like the thing that holds everything together, all electrons, like your sense of touch, sight, everything that you can sense is from electromagnetic vibrations. Like even things that you hear, you can view that as electromagnetic vibrations between the air molecules, which are all charged. Like it's all, every atom and every molecule is like a negative magnet, like in the air. So it's a bunch of negative magnets in the air repelling each other. Like that's what, like imagine a bunch of magnets that were all negative. Just the tiny little magnets. And then they just stack up on each other in the air. With a super light weight to magnetic ratio, so they just bounce around at the slightest perturbations. Yeah, let's watch it. I just got to keep an eye on Bridget. So when you're sending electricity down wires, like from the power plant to a light bulb or your cell phone, it's traveling in the field that is trapped between the two wires. So the wire going out and the wire coming back creates like a laminar flow of electromagnetic energy, and the only evidence of that flow is just in these ripple currents of the electromagnetic field of the atoms in the wire. And so people detect that as electron drift or electron flow. And so it's like part of the phenomenon, but most of the energy, just like you saw in the laminar flow of that water fountain, it's the surface is all we see. Anything that we can see or perceive is just the surface of that energy that's moving. So most of it's in the field, which then you have different devices like light bulbs or whatever that take that the potential of that laminar flow to become a surface, right? E equals mc squared. So it's like all of the water, all of the energy contained in a atom or in a globule of energy can become surface, the same way that like all of the, right? So water can be bulk water, where it's like not the surface and you see through it and it's kind of invisible. It's like this invisible medium supporting all things that lies underneath all things. That's the electromagnetic field. So like when you start to see that at all levels, it's fractal, then you understand electromagnetism, Newtonian physics, solar system dynamics, radio, like it's all one phenomenon. And you can use water as an analogical crutch to start thinking in those terms.